welcome to another day on the Journey Chez Chem. Please do the 2 warm-up questions to the best of your ability. And they are a bit challenging, but they're a great review for our assessment tomorrow. So we'll be back in a moment. Now the question in number 1 is very similar to a question on the assessment, and it's worth 20% of the assessment grade. Therefore, that would be 20 points. I will ask a variety of questions just like I have done in number 1. So this is good practice. Now we know that these types of problems where we're asking for a net ionic equation are double displacements. And therefore, the inners and the outers trade places. And I get lithium acetate plus lead 2 carbonate. That would be worth 4 points. Now, I also need to get a balanced formula equation. Lithium has a +1 charge and carbonate is -2. So my formula has to come to 0. Plus lead is +2 and acetate is -1. And those would be my formulas. Now the inners and the outers are trading places. Therefore I get 2 lithium acetates and lead 2 carbonate. Lithium is +1 and acetate is -1. Therefore, it's just lithium acetate written in this form. And because I had 2 lithiums over here to balance with the carbonate, I had to put a coefficient 2 in order to balance the number of atoms. Now I look in my table of solubilities at the negative position, and I know that acetates are dateless. All acetates are soluble. Therefore, acetate, lithium acetate would be aqueous and would be continuing to float around in solution as ions. Now carbonates are mainly insoluble except for the group 1A and ammonium ions, and lead is not one of those. Therefore this is my solid, and I will underline it in order to get my net ionic equation. This would be my solid. Now everything that's aqueous I will break up into my ions. Therefore, I have 2 lithium ions aqueous, plus carbonate ions aqueous, plus lead ions aqueous, plus 2 acetate ions aqueous, and I get 2 lithium ions aqueous, plus 2 acetate ions aqueous, and lead 2 carbonate is a solid. Therefore, it does not separate into its ions. Now, things that are identical on both sides of the equation are my spectators. They're not doing anything. Therefore, my lithium and my acetates are my spectators. They are the spectator ions. So they would be lithium ions and acetate ions. And it's not an ion without its charge. You must write the charge. What's left when I remove the spectator ions is my net ionic equation. And that would be my carbonate ions, aqueous, my lead ions, aqueous, and it forms a solid of lead 2 carbonate. And I could also show an arrow down showing that it's a precipitate, or underlined, or a little S, or a little CR. All of those designations show me that it is a solid. And that's the answer to number 1. Number 2, we have types of equations where you must predict the products. And you will have 8 of these on the assessment tomorrow. And they are worth 4 points each for the equation and 2 points for identifying what type of reaction it is. Now, in the first one on the assessment, I will just give you the compound, and you will need to know that you will have to decompose it. Nitric acid is HNO3. And whenever I decompose an oxyacid, I always get water and an acid anhydride. So I get some form of nitrogen and oxygen combined. And the way I know what formula it is by the charge on this nitrogen. Well, oxygen is -2 times 3 is -6. This is a compound and it's 0. Hydrogen is +1 plus X, therefore nitrogen is +5. I could have also looked at the nitrate polyatomic ion and set it equal to -1. Oxygen again is -2 times 3 is -6. And in this case, nitrogen is still +5. In the second one, zinc is reacting with, oh, I'm sorry, I have to finish A. So nitrogen is +5 and oxygen is -2. Therefore, my formula must come to 0, and 10 is my common multiple between 5 and 2. Therefore, I need 2 nitrogens and 5 oxygens. And because I have 2 hydrogens here and 2 nitrogens, I need 2 as a coefficient in front of the nitric acid, and then it's balanced. Sorry about that, but at least we caught it. Now in B, we have zinc reacting with hydrochloric acid. And this is a single displacement where the zinc is displacing the positive hydrogen. Metals are positive, and so they will displace the positive position. And we get zinc chloride, and zinc is +2, and chlorine is -1. Therefore, I need 2 chlorines to get that compound to 0. And I displaced my hydrogen, and hydrogen is a diatomic molecule. But when it's by itself, it must be H2. Therefore, I'm going to put a 2 in front of the hydrochloric acid, and then my number of atoms balance. Now, this next one, I am decomposing magnesium hydroxide. Magnesium is +2, hydroxide is -1. Now, whenever I decompose a base, or metal hydroxide is a base, I always get water and a base anhydride, and magnesium is +2 and oxygen is -2, therefore I get MgO. That kind of reminds me of a song about a dog, but maybe you don't remember that song. Anyway, MgO, and now I believe it's balanced. Now the final one is potassium phosphate. Potassium is +1 and phosphate is -3, so it requires 3 potassiums to get to 0. And I am going to write HOH so that I see how my water separates. Now I know when I have a salt and water, I'm going to get an acid and a base. My acid is phosphoric acid, and my base is potassium hydroxide. And because I have 3 potassiums here, I must have 3 potassiums here. And therefore, this gives me 3 hydrogens plus 3 hydrogens is 6 hydrogens. And therefore, I must have 3 waters in order to balance my number of atoms. And that's how you do number 2. Now, the assessment that you have coming up tomorrow will have a net ionic type of equation like you had in number 1 of the warm-up today. That's worth 20 points. Then you will have 8 equations where you will have to complete and balance with formulas and identify what type of reaction. That's 48% of the assessment. You will have 2 equations where you have to put in the coefficients to balance the number of atoms. And you will also have to give the general equations for the different types of reactions. And that's about it. So you should be prepared. You've had lots of practice, and I know that you'll do well. So I can't wait to see you tomorrow. Bye.